my name is Redo Meyer and I'm the tech lead for Google's Android Developer Relations team. This efficient data transfers DevByte is going to look at techniques that you can use to reduce the battery drain of your app without affecting the freshness of your data by adapting the frequency of your updates based on context. In other DevBytes, I've explored ways to analyze your app's transfer profile and optimize it using techniques like prefetching, bundling, and sync adapters, and Google Cloud Messaging. The goal is to ensure that you never initiate a transfer that isn't related to a required data sync. But if you have server data that changes rapidly, such as breaking news, weather, or sports scores, triggering an update every time there's an update on the server is still going to tax your servers and drain your user's battery, particularly when your app is in the background. Now, the aim of this DevByte is to go beyond limiting transfers to when they're valid and start considering device state, user behavior, and impact on the user experience to minimize the number of updates that we actually perform. In my DevByte on Google Cloud Messaging, you learned that you can set your server messages to be delayed when the device is idle. As a result, your messages will be queued and that queue is collapsed so that when your app only receives one message when the device becomes active. Now, that's a useful start as it prevents multiple updates from happening when the user isn't actually using the device. In other DevBytes, on using the sync adapter, you saw how to group all of your app's transfer methods within your sync adapters on perform sync method. A sync adapter can be triggered a number of ways, including GCM tickles, client-side changes, scheduled updates, or user actions, like selecting a new song or browsing an article that hasn't been prefetched. Within our perform sync handler, we need to determine which of these triggers are sufficient to initiate a new transfer. Starting with scheduled updates. Periodic updates are a great way to ensure your app never seems stale, and that users aren't left waiting for significant amounts of data to be synced every time you open their app. Of course, stale is relative not only to the type of data that your app displays, but also how frequently a user opens your app. Periodic updates work well for apps like newsreaders, where the frequency of news articles makes sending a GCM message to every app whenever new articles are available massive overkill. And the freshness of news isn't critical unless the user happens to be actively browsing it. In this case, performing a background refresh every hour might be a reasonable approach for users who open the app several times a day, as it ensures that they see fresh headlines every time they open the app, even if the device hasn't been online for a while. But it's wasteful for a user who only reads the news headlines once each morning. Now, you can mitigate this by reducing the background update frequency based on the recency of app usage. In this snippet, we check to see if the app has been opened since the last time we performed a refresh. If not, we double the period between refreshes. Now, each time the app is opened, we reset that counter, so as a result, your app has fresher data for regular users, while those who open the app only once a day or once a week are saved the resulting battery drain. Now, if you're reducing the frequency of updates to reduce the battery-hungry use of the cell radio, we might be able to mitigate some of these choices based on the current battery level, charging state, and connectivity type. It's generally good practice to minimize background updates when they don't result in notifications, but the impact of performing updates while the device is charging over AC is negligible. So you can reconsider some of those assumptions when the device is connected to a charger. Conversely, you can listen for a broadcast telling you that the device is low on juice, and reduce or eliminate background updates completely until the device is charging. Of course, just because you're connected to power doesn't make your downloads free. Even if you're not concerned with the power drain associated with 3G radio, you should still be conscious of the amount of data that you're transferring. You can also monitor the current internet connection to help mitigate against that. If we're connected over Wi-Fi, bandwidth use isn't an issue and power use is significantly lower than when compared to a cell radio. That means you can more aggressively react to send to sync messages when client-side or client-side content provider changes, when you're in the foreground and potentially even in the background, especially when we're also connected to power. A good example of this scenario is when the device is docked. Monitoring for the device to be in a docked state can be a useful shortcut, letting you know how to check for connectivity and charging status and potentially modifying the frequency at which you perform syncs. You can check the current device state each time you receive a GCM tickle or a local content provider changes to determine if you should actually perform the update. Or you can monitor changes in the device state to alter your sync adapter settings to stop or start listening for changes. Likewise, you can send a message to your server altering the frequency at which you want to receive those send to sync messages. For example, you may want to receive a tickle after there are 10 new headlines, or only when there is a breaking news story in your area, or not more frequently than once every 10 minutes. You might also want to consider the context of the user themselves. Using the new activity recognition APIs, you can choose to alter the foreground update frequency based on what the user is doing. In this example, we might artificially limit the update rate when they're doing anything other than standing still, on the basis that users are less likely to be looking at the screen and browsing. Now, we can use a similar technique as an alternative to periodic updates. Rather than update the app once every 24 hours to ensure it's fresh in the morning, you might check for the tilting activity after a prolonged period of being stationary, as an indication that the user has been asleep and has now gotten up in the morning, so it's worth refreshing their data. Now, having introduced a number of possible ways to skip or delay transfers, it's important to check the cause of the sync to ensure that you're not delaying transfers that will affect the user experience directly. Any manually initiated transfer, so anything that's necessary for the user to continue using the app or browsing, needs to happen straight away. When using sync adapters, you can determine this as shown here. Now, in any case, while it can be useful to alter the frequency at which we execute a sync, fundamentally we're still depending on techniques like sync adapters and Google Cloud Messaging, as described in other DevBytes in this series, to ensure that we only ever consider performing a sync when data has changed, either on the client or on the server. Even then, we want to avoid performing a sync that could be delayed without impacting the user. In most cases, that means being very conservative with background updates for anything that doesn't result in a notification being displayed.